So hopefully everyone knows where they're at, that they're supposed to be here. So this is the topic of the workshop for this month is we're going to walk through basically how to write regular expressions, which, yeah, is something that I have done for many years on and off, but didn't really know what I was doing. And that may be the case for some of y'all, or maybe you've never seen them before, which is also totally fine. Hopefully this will be a fairly soft and somewhat comprehensive-ish entry to like what all the different regex syntax is. So yeah, and this is supposed to be pretty interactive. Feel free to stop me and ask questions, either by unmuting yourself. Feel free to put questions into the Zoom chat. It is just me today. I don't actually have anyone helping me, but I'll try to make sure I stay on top of all of that. And then also stop regularly so that people have space to interrupt me too. So yeah. And then one of the other things that I will probably use regularly throughout are the Zoom reactions. And so I'll ask periodically for y'all to click on a reaction so that I know where everyone is at. And so hopefully with your Zoom interface, I can't really show everyone, but hopefully you have some sort of reactions button or tab. And so you can click on like the two that I'll probably use the most. There's a green check mark. And then there's also a red X. And so I'll periodically ask people like, okay, if you get this or you were able to make it work, give me a green check mark. If you're struggling or have a question or anything else, do a red X. You can do those at any time too, so that I know if you have questions or if you feel like it's going well. Helps give me feedback, especially in the virtual platform. So yeah, I think that's most of the sort of mechanics. So anyone have any questions or anything before we go on? Try to figure out how to turn off this reaction. There we go. Okay. Oh, I guess before we get started with the content, I want to make sure everyone knows who we are and what we're doing so that you know whether or not we can help you, basically. So our group is called the CCT Data Science Team. And this is a screenshot of our website. This is probably the best place to go to figure out what we're doing and how to get in touch with us. So the URL is down here. And I'll share these slides with y'all too, so you can look at it later. But this is our website. We are a small group of data scientists at the University of Arizona. We primarily help people that are in CAL's departments and extension and the experiment station. But we can help people across campus also, anyone researchers across campus, but those are the people we tend to focus on. And we help people in a variety of different ways. So we teach monthly workshops like the one here. We also teach a workshop series that we'll be doing once a year from now on that actually a couple of people on this call attended that are sort of for reproducibility and open science practices. We have, our group has drop-in hours once a week on Tuesday morning. So if you have a quick question or you just want to talk about programming or your research or anything, feel free to come by and chat with us. And then the last sort of thing we have right now in our suite of programming our incubator program. And so these are basically one-on-one collaborative experiences where we work with you and possibly a group of people, and we help you build some sort of tool or data management plan for your research. So yeah, they're like sort of short-term scoped out projects. We've done things like help people build Shiny apps. I think there's a bunch of examples down here. We've helped people at University of Arizona build Shiny apps, create databases, visualize data in different ways, write R packages. Yeah, our group can do a lot, and we would love to help you. So if you're a researcher at U of A, in particular in one of the CALS departments, and you think we could help you, come talk to us at our drop-in hours or email us. And we're always looking for more folks to work with on different projects. So yeah, that's the spiel. Have to give it to everyone every time just to make sure everyone knows what we're doing and whether or not we can help. Okay. So let's get right into it. Let's start talking about regular expressions. So I will say that as I said at the beginning, I am not an expert on regular expressions. I've used them on and off throughout the years, but didn't really fully understand like how they worked or what was going on. I didn't have a very good mental model for regular expressions. Now I feel like I have a pretty good mental model that I put together the materials for this workshop. So we'll go ahead and talk about what some of the terms are before we start jumping into all of the different regular expression syntax. So first question you might have, or that we should all be on the same page with, is what is a regular expression? And so this is basically a sequence of characters that specify a pattern within a string. And so you can see here, I put a couple of examples of a regular expression characters or phrases. And we will actually, well, by the end of this, you'll know actually what these stand for, what they represent. And so basically, this is a really powerful tool for being able to identify different types of patterns that you're interested in within a bunch of different strings. Okay, you might ask yourself, well, I don't actually know what a string is. It's another important question. A string is just a sequence of characters. It can be any characters you want. I put a couple of examples here. There can be numbers, letters, special characters, spaces, also Unicode characters, but we won't really talk about those here. I think it's a little bit of a niche subject. But yeah, so a string is basically a sequence of characters. And then you can have a bunch of strings if you have a bunch of different sequences of characters, which is what most people, I think, usually work with. And so regular expressions are good for looking for patterns within a string or a bunch of strings. Okay, and the last question, I maybe have used the term regex. Well, it was in the title of the workshop. Regex is just an abbreviation of regular expression. So I might go back and forth between calling them regular expressions and regexes. I also think people pronounce that word differently too. I think some people use regex. I don't know if there's like a canonical pronunciation for it. Pronounce it however you want, I think. So yeah. Okay. So just to talk a little bit more about context for what regular expressions do. Regular expressions are great for processing any sort of text to data that you have. You can do a lot of different things once you have a regular expression for a pattern of interest. So if you're looking through a bunch of strings for strings that have a certain pattern in them, it's really helpful. You can also use them once you have a regular expression. You can basically do like find and replace, like what you do in a Word document, where you can go through and find certain sequences and then replace them with something else. Like you could go through and replace every instance of an X with a Y. I mean, that's a very simple example, but something like that, but a little more complicated. And you can also use regular expressions to look for accuracy in your strings. So if you have strings that might be misspelled or something like that, it's a way of finding those misspellings, and then you can potentially correct them too. So really, this is a really powerful tool. And then you actually use regular expressions to do something with your strings in programming languages or on the command line. And so hopefully at the end, if I don't run out of time, I'll actually demo in the R programming language, just because that's what I'm most familiar with. But I'll demo how you can actually then use these regular expressions to do these tasks with strings. And so most of the time, there's multiple flavors of regular expressions too, so it'll depend on what programming language you're using. Most of them use some sort of Perl or POSIX-based sort of approach. I know in R, I think they use POSIX for some of their flavor for regular expressions. And as I said before, if you're working on regular expressions and you're not having trouble figuring out how to get them to work in the way you want, feel free to come ask us for help at our drop-in hours. Okay. So actually, maybe I'll stop here for a second, see if anyone has any questions or comments. It's also possible some of you know more about this than I do, so feel free if you do to like pipe up and add any interesting information.
I have a question.
Yeah.
So when I try to do this, I usually do it on the command line, Linux, I guess, environment. So these will be transferable, or somehow we'll be able to use them in the command line or R?
Yeah.
Okay.
I mean, it has a lot of the same, yeah, so you can write regular expressions and then they should be somewhat portable to different programming languages or to the command line with some minor modifications.
Okay.
So you have to kind of figure out what flavor any of the particular platforms you're wanting to use are using. So yeah, and I think if we get to the R stuff, you'll be able to see, or I can show at least one example of that. Yeah, and I assume, I mean, I think most programming languages will have like guides for how to modify regex to work. Like, so Python probably uses a slightly different flavor than R than, I don't know, Fortran or C++ or something. Yeah, good question. Okay, we'll keep forging on ahead. Okay, so I'm just going to walk through kind of like the framework for how you work with regular expressions, because there's the regular expression itself, and then there's doing something with the regular expressions. So your first step is that you're going to want to gather up your strings or string that you're wanting to extract a pattern from. And so I put an example here. Let's say you have these 4 or 5 strings. And again, I will say some of the examples that I use for the syntax, like explaining the syntax, they're kind of like simple toy examples. But I also have put some exercises throughout that I think get a little bit more at what you might actually realistically be doing with regular expressions. But to start with, like, we're starting very basic. And so some of the examples might seem a little like, you know, there's probably easier ways to do some of this, but this is basically to illustrate the concepts. So be patient with me on that. But so yeah, as an example here of some very simple strings that you might want to extract something from, we have cat, hat, bat, rat, and sat. And then once you have your strings, you figure out what the pattern is of interest to you. So let's say here we want to just get all of the strings that are animals as opposed to other things. So cat, bat, and rat are animals, hat and sat are not. So your third step will be to figure out what the regular expression is for that pattern. And so for this fairly limited list of strings, we can figure out a regex that will match just the animal names out of those 5 options. And so you see there's some brackets, some letters, and we'll talk about how to construct this. But basically, this is the regex for just selecting for the strings that are animal names. And then the last thing you do would do whatever you want to do with that regex in your programming language. So whether you just want to get those strings, if you want to subset them in some way, if you want to exchange one part of the string for something else, you'll do some sort of task. And so the focus of this particular workshop is on this third step here. And so this is a little bit narrow in the sense that we're just going to be talking about how to construct regular expressions, what a bunch of the options are for doing that, and how to start putting them together into like more complicated sequences. We can also potentially at some point do a workshop on this 4th thing. So if you're interested in figuring out how to do this in R or how to do this on the command line, those are other workshops that we can also offer in the future if you're interested. Or if you know a lot about doing that, you could help us teach one. Okay, so this is a basic workflow for how you use regular expressions to do tasks, how to extract or subset or just find strings with certain patterns in them. So yeah, we will dive right into how to construct these regular expressions. Does anyone have any questions about this or comments? Okay. So yeah, so there's a bunch of free online tools that are really helpful for figuring out what your regular expressions are supposed to be, used for, you know, validating, for testing, for visualizing what your regular expressions look like. And so this is a really common one right here, this regex101.com. And this is the one that I'm going to use throughout to sort of demonstrate how these regular expressions work and show like examples of which strings they work on and which they don't. This is a really cool tool. There's probably some parts of it that I haven't really used a whole lot yet. But as we look at our first example of regex syntax, we can talk about what some of this different information is on here. Another cool tool I found while I was preparing for this workshop is this regular expressions visualizer. And so basically you can put your regular expression in here, and then it will give you a visual display of what that's supposed to be looking for. That's not what I wanted to do. This isn't a very good example. I'd have to think of something more complicated so it looks interesting. But I have a screenshot here on the slideshow that shows a more complicated regular expression. And then it has basically a visual, the visual format of that. So it can help you figure out if it's doing what you actually want it to be doing. So that was really neat. But yeah, like I said, we're going to go ahead and we're going to actually use this regex 101. So I encourage y'all, as we work through both the different types of syntax and the exercises, we'll do a bunch of exercises, to go ahead and actually type in things to this regex 101 tool, to start playing with the different regular expressions and testing them out for yourself. And I may have made some errors along the way too. So if you find them, feel free to tell me. Oh, we had a question. Is there an established list of regular expressions? I think that there are a lot of different possible lists online, and it can get really complicated really fast, but there are. So at the end of the slideshow, I have some resources linked. And I did find, if you just Google for regex cheat sheet. So I've linked to this first one here. And I use this for developing some of these materials. But yeah, so there's a lot of regular expressions cheat sheets that will list a lot of the different options. And this one actually gets a little more detailed and includes some things that we won't really cover here. Yeah, there's lots of resources online, including this is one that I thought seemed pretty useful. And I don't think there's really per se an established list, because it really depends on what flavor of regular expressions you're working with, because it can vary so much between the different kinds and whichever programming language you're using. So actually you can see on here, yeah, like for example, this this piece of regular expression syntax is particular to certain languages. And so they try to note some of those in here, like this one's, you know, Python specific one looking for a vertical tab. Yeah, I think this is one of those things that is really useful to know a little bit about. But then if you're wanting to do very specific or really, really complicated things, it's probably something you can get really deep into also. So yeah, it's a really good question. So yeah, it's possible at this point, you know enough, you could just look at one of these and like figure it out on your own, but we're actually going to walk through just a lot of these different types of regular expressions. Okay, so like I said, yeah, we'll use this regex 101 regular expression tester like throughout this workshop. Okay, another bit of prep, just so you are sort of oriented to how I tried to set up looking at these different examples of syntax, is how these slides look with the different syntax on them. So on each of these slides, I tried to list what category that regular expression falls into. Then in this box right here, a description of what it's supposed to be looking for. Then I put sort of a very simple example of how to use the regular expression down here. And then at the very bottom, I tried to list out these 3 strings and then list out 2 of those strings that would be a match for the regular expression, and then one example of a string that would not be a match or would not be matched. So just to orient you to sort of the like template I tried to use to make this really consistent. Because we're going to go through a bunch of these. I think there's maybe 15 or 20 of them. So yeah. And it'll probably be more clear what I'm talking about when I actually go through one of these, but I can go back to this too. Okay, so the first thing we're going to talk about is finding digits within strings. So numbers, basically. So to start off with a really simple regular expression. So as I said before, the category for what we're talking about is up here. So we're talking about digits to start with. And then this first regular expression is to find just a digit in a string. So any digit in a string that potentially has other stuff in it too. And the syntax for that is this /d. I always mix up / and /, so I'm sorry if I do that. I think this is a \, right? Let me double check on that to make sure I have that correct. I know where they are on my keyboard, so. Yeah, so this is a \. So / and then a lowercase d. And so that's a regular expression for finding a string or the string that has a digit in it. And so for our examples down here, I have 3 strings. And so this first string would be a match. The second string would be a match because they both have numbers in them. This third string would not be a match because it's just letters. Okay. And like I said, oops, that's not what I want to do. Zoom stuff's in the way. Like I said, I want to make sure that we're actually looking at examples for how to do this using this tester right here. I wish my screen were bigger. I don't know if we'll be able to fit this all in. Okay, so if you want to go ahead, and this is where I suggest following along. So in this regular expressions online tester, so I guess I forgot to mention this, but regular expressions usually always start with this /, but because they all start with them, this tool just has it there sort of permanently. But so you type in your regular expression here, and then you can type in one or many strings, and it'll tell you which ones are a match and which ones are not. And then it'll give some detailed information here about your regular expression and when it applies, and then what matches. So if you want to go ahead and type in, I'm going to type in, you can kind of see it here, but I'm going to type in the regular expression at the top, and then I'm going to type these 3 strings below. And so we have our \d, and then our strings are 1, 2, 3, and then you can just hit enter to enter another string, ABC 1, 2, 3, and then ABC. Here, let me make this a little bit bigger too. Okay, and I'll give everyone a minute if you're following along to go ahead and type it in, kind of like what I have here. And I'll put the link to this in the Zoom chat too. Okay, if you're following along and you have successfully typed these in, do you want to go ahead and give me the green check in the Zoom reactions? And of course, it's fine if you want to be here and just watch and don't actually want to type anything in or follow along. That's also okay. No pressure. Awesome. Looks like most folks. Okay, so you should see up here in the explanation, this is useful information here that tells you what's going on. And so it says here \d matches a digit, which is equivalent to this expression, which we'll talk about in a minute. Then at the bottom, we also have some global flags that they applied. Those are right here. So G is for global. That means that it applies to all the matches. And then M just means that it's looking for it in multiple lines. But those are sort of, we don't need to worry about those too much right now. The important thing is this information at the top. It basically tells you what your regular expression that you typed in is looking for. And so we can see down here, it shows your matches in this blue color. And so we can see that the first string, there's a match, there's a digit, and second string, there's some digits, and then the third string, there's not. And then they also have those matches here in this list, specifically laid out which line and then which character. Okay, and so that's our first example of a regular expression syntax, which is this /d, which is looking for a digit, any sort of digit anywhere in the string. And so we're going to sort of build these up. We're starting with really simple things, and we'll do some exercises along the way to practice applying these to different types of strings we'd be looking for. Okay, so I'm going to switch back to my slideshow. Sorry. I'm going to kind of go back and forth between these two a little bit. Okay, so that's the digit in a string. We did this in the regex 101. Okay, another thing you can do is if you're looking for just one particular digit in a string, let's say in here for the example is, let's say you're looking for a 3. And so again, we have some strings down here. If you use 3 as your regular expression, it will match the first 2 of these strings, but it won't match the third one because there's no 3 in it. And again, these are very simple, almost trivial seeming examples, but then once you start putting them together, that's where this gets really useful. Okay, another thing that you can do for specifying digits is if you want specific consecutive digits in a string. So here, if I put in as my regular expression 3, 4, it will only return strings that have a 3 and a 4 right next to each other somewhere in the string. So that's why this matches the first 2 of these strings. But in this third one, there's a 3 and a 4, but they're separated by another character. So that one would not be considered a match. Okay, and Erica asked, so is that \d 3, 4? No, it's just 3, 4. Okay, and so let's go back to, I'll go back to the regex 101 tool and actually show that. So /d is one regular expression that we put in and we tested down some strings. But now what I was showing you before, these are different regular expressions. So here, if I put 3, 4 in, well, nothing gets returned. Let me do this instead, 2, 3. So let's say our regular expression is just 2, 3. And then for the strings that we had in here already, we can see that the first and the second strings have that in it, and so they're considered a match. And then the third one does not have 2, 3 in it. And then, so we can have a string that has the numbers 2 and 3 in it, but if they're separated, it also won't return as a match. So if we do, 2 at 3, something like that. Yeah, so for right now, yeah, I'm trying to walk through kind of like very specific examples of different types of syntax. And so, yeah, the stuff that's in this sort of blue box is supposed to be an example of a regular expression to sort of illustrate how to look for this type of pattern. Okay, very good questions. Keep asking questions if anything's confusing. This is the first time I've taught this material too. So sorry, y'all are kind of like the test case for it. So yeah, feedback on how this is coming across is also really helpful to me too, so I can figure out where to make it better. And I think that's it. Yeah, so those are a couple of the different types of syntax you can use to look for digits. So either just generally any type of number that's in a string or specific numbers that are in a string. Okay, so the next thing we'll talk about are doing ranges or different options for one location. Okay, so how we specify these ranges are we use brackets. And so this right here is an example of a regular expression, bracket 3, 4 bracket, end bracket. And so what this is doing is that it will look for at least one of these characters in the string. So it'll look for either if there's a 3 or if there's a 4. And so you can see here, 1, 2, 3 would be a match because there's a 3 within this string. In this one, there's a 4 in the string. But then this last string would not be a match because there's no 3 or 4. And so it's only looking for a 3 or a 4, or if both are there, it'll show up. So I'm going to go ahead and jump over to the regex tool. See if I can make this a little smaller. There, yeah, now we can actually see it. I'm going to type in this regular expression, which this specific one is 3, 4, but you can put any numbers you want in here. This is just the example I'm using. And so I have strings, example strings here. So you can see it returns that there's a match in the first string, a match in the second string, and then no match in the third string. So let's say instead of looking for, if I wasn't looking for the letters 3 and 4, I'm looking for the letters 5 and 6. So when I change what's inside those brackets, it'll change which strings actually match. And you can put more You can put more numbers, and you can actually put letters in here too, and we'll talk about that a little bit later too. But you can put more numbers or more letters in here, and it will still do the same thing where it will look for at least one of those characters in your string. And then, yeah, the explanation over here in the regex 101 also says that too. So it says it's trying to match a single character present in the list. And this list right now just contains the letters 5 and 6. Okay, so that's generally how you use brackets if you're looking for at least one of the things in a list of different characters. So let's say you're looking for a bunch of different numbers, not just 3 or 4, and they're all consecutive. You can put those numbers in and separate them by a, wow, my brain totally just blinked, by a dash. So for example, we can go back over here, and if we type in 0 through 9, now every single one of our strings is a match because they all contain at least one number between 0 and 9. We could change this if we wanted to too, if we wanted to just look for all the numbers from 1 through 9 instead of 0 through 9, and we add a string that's just zeros, that one will not be a match now. So that's how you can look for a range of numbers by specifying the range. Okay. And like I said, you can also put letters in here. We will talk about letters in the next section, but we're just sticking to numbers right now to keep it a little simpler. Okay, and then the last bit we'll talk about right now for ranges is using the square brackets, but then putting a caret at the very beginning. And so this is a little complicated for this one, but it looks for there being at least one character that's not in the brackets in the string. And so for this example here, this regular expression, it's looking for a string that has at least one character that's not a 3 or a 4. So these first two strings are a match, but then this third one is not because it only has 3 and 4 in it. Okay, and so this might seem a little like esoteric, like when would you ever use that? But I've already seen some good examples of where people were using this. Like if you're looking for a specific set of letters and you don't want other letters, it can be really helpful. Okay. So that covers just some of the possible regular expressions that we can use to identify strings with digits and ranges of different digits. And so I try to kind of condense that into this table here, hopefully as an easier reference. Oh, and you'll note actually that this is true. 1 second. Make sure I'm not misspeaking. Yeah, so I'm pretty sure that this \d is equivalent to the 0 through 9 in brackets, in square brackets, because it's basically looking for any digit. Okay, so let's go ahead and do our first exercise. And so I'm intending for this to be a little bit hands-on so people can start to get to some practice because you learn this material a lot better. I see a good question. How would we find a range between double or triple digits? Okay. Now I'm going to start thinking on the fly. So, and also I wanted to say, even before we start the exercise, that I think there's a lot of different ways you can do this, a lot of different ways you can set up your regular expressions to look for different patterns. Just like in all of programming, there's multiple different ways you can reach the same conclusion. And some of it depends on kind of like what you're really specifically looking for. But off the top of my head, I think we maybe haven't learned enough to be able to answer a question, Laura. So sorry if people are not watching the chat. Laura asked, how would we find a range between double or triple digits? So you're saying like if we wanted to look for a number that was between like 10 and 100. And I think we have not yet learned how to do that. We'll talk about Yeah, or between years. I think the best way to approach that is by using curly braces. And then you can specify multiple digits. So if I don't remember to get back to your question, once we do curly braces, can you remind me, please? It's a really good question. And it's also testing my knowledge. But I think right now we can't do that with what we know. Okay, cool. Okay, so let's start with an exercise. I try to sort of set up the exercise template similarly to the way the like the regular expression syntax was, but just walk through this. So we have our exercise with our question. Our question is, can you figure out a regular expression that matches every string containing either 150 or 160? And so as examples of strings that would match, these should all match because they all contain 150, 160. And then these should not match because they don't have a 150 or 160 all together like that. So for folks who are participating, if you want to go ahead and take a few minutes, you can use regex 101 to try to figure out a regular expression that would work for this. And I have one answer. It is possible y'all can think of other answers that I was not clever enough to think of. So I'm going to go ahead and let everyone think about that for a couple minutes. I was actually going to maybe set a timer for these exercises, so don't let them drag on for too long. Pop up this little timer. We'll set it for 2 minutes. Oh, geez. Okay. Okay. That was a couple minutes. Looks like a couple people at least figured out some solutions. Do folks want to either put their solutions in the chat, or you can go ahead and unmute yourself and just say them if you want? In the meantime, I'm going to go ahead and put these strings into regex 101. So yeah, I have my, oh, and I want to get rid of this old regular expression. Okay, sweet. So Savannah, thank you for providing a response. Oh, geez. Apparently I cannot. I thought I could copy from the Zoom chat. But apparently, oh, there we go. Okay. Oops. Okay. Okay, yes. So great. Yeah. So both of these work. Awesome. Thank you, Savannah and Erica. So this is Savannah's response, which totally works. We've got, so the first option needs to be a 1. The second option needs to be a 5 or a 6. Third option needs to be a 0. And so you can see that that matches the first 3 strings, which is we wanted it to do, and then does not match the following 3 strings, which is perfect. Erica has the slightly more simplified version of this. So you don't necessarily need these brackets around the 1 and the 0. Though it can be helpful to keep them, keep them a little separated in your mind. But it also works if you have 1, then 5 to 6 in brackets and 0. Additionally, you can actually also take out the dash if you want, or you can leave it in. So yeah, awesome. That's perfect. So like I said, many, many ways to do this. And it'll be really interesting because you'll probably think of some creative ways to answer these questions that I wouldn't have thought of. Also, I probably have not thought about every single edge case for some of these example regular expressions. And so there might be some interesting things that pop up because of that too. Like, oh, it works for this string, but this other string gets returned and we don't want it to be. So do you have any questions about this exercise? Nope, perfect and clear so far. Great. We're off to a good start. Okay, so that's digits and ranges, just to start with. The next thing we're going to talk about are characters. So how to search for different letters, which there's some overlap with the digits and then some different things going on. Okay, so for the first thing, you can look for a character just like you can look for a specific letter. So if you want to look for any string that has, here the example is the lowercase d. Yeah, you just type in D and then it'll tell you which strings have a D in it. So this third one does not. But one thing you want to note about this, like I did sort of spoiler alert, my own comment, is that the characters are case sensitive. So this will look for a lowercase letter, a lowercase d, not for an uppercase d. So it will not find the uppercase d's in this last string here. And we can see that in regex 101 if we want. Is that if we're searching for a lowercase d, there will be no matches in this string because they're uppercase d's. Keep that in mind. Oh, and you can see one of the useful things that regex 101 does is it says there's no match here. And then apparently they have a debugger. I haven't used this yet. I haven't really explored it, but it might be really helpful. Sometimes it can be really helpful to read the explanation too, because as I was figuring out some of these, I'd be like, I don't know why this isn't working. And then reading the explanation would help me to be like, oh, that's why. Okay, so those are upper and lowercase letters, just individual ones, or you can put them together like we did with the numbers too. Like if you change this to DOG, it'll only match the first one. Like I said before, you can also use the brackets for characters. So this, for example, it will look for any character that is A, B, or C in the string. And so we have A, B, and C, and this is first string, so it definitely matches. The second string has a C in it, so it matches. The third string does not have any of those in it. So you can use this with different ranges of letters too. You can also combine letters and numbers to look for multiple different sort of sets of those things. And so what you do is you want to put in, so kind of to separate this out into 3 chunks, you can look for different ranges of capital letters, different ranges of lowercase letters, and then numbers. And they do kind of just smush them all together within the square brackets. So it's kind of like a hard thing to look at with our brain with no spaces. And you'll note the specific example here I put of using ranges and brackets is equivalent to, it's any alphanumeric character, and that's equivalent to this \W. So we had the \D earlier for any digit. \W is for any alphanumeric character. So it won't include things like special characters. So you can see these string examples down here. Neither of these 2 regular expressions will match with this third string. And then you can change what these ranges are too. I used, all of the letters and all of the numbers, but you could restrict them. Like say you don't want any zeros, so you could change this to a 1. What's next? Ah, yeah. Okay. People have questions right now about looking for letters before we move on to quantifiers. Yep. Okay. If you do, feel free to speak up, and we can always go back through some of these too. Okay. Quantifiers are for looking for repeated occurrences of some characters. And so we've got, I think, 3 different quantifiers that we'll talk about. So the first one is this plus symbol. So if you use put a plus symbol after some particular character or number, it will look for 1 or more occurrences of that letter or number. And so here we have just the letter capital A with a plus symbol after it. And so this regular expression by itself, it will match the first 2 of these because there's at least one capital A. It will not match the third string because there's no instances of the letter A. And these might seem kind of weird, like by themselves, maybe, or just with one character, they're not quite as useful. But once you start combining all of these pieces together, that's when it can become really, really useful. And we'll see an example. I think that the next exercise is about different spellings of names. I think that's the next one. So we'll get through these and then maybe it'll be more obvious why they're useful. Another quantifier that's used commonly is this one for 0 or more occurrences is an asterisk. And so this is it's weird to show example strings for this because it's like, this will return a match for any string that's got something in it because it's 0 or more occurrences of the capital A. And then the third type of quantifier is a question mark. And here, to try to make it a little more interesting, I typed out the word files and then put a question mark, and it'll look for 0 or 1 occurrence exactly. And so for here, it will find the string file or the string files. Oh, but I didn't include a non-match would be, I think it'd be hard to do. I mean, nothing would be I don't think it'd be hard to do a non-match. But yeah, this could be useful for, this is an example of looking for a string that could also be a plural version of itself, is what the 0 or 1 occurrences can be useful for. How do you search for a question mark? That is an awesome question. Yeah, we will talk about escaping in a bit. And so the way you look for these special characters as themselves is through escaping using a slash. Cool. I always like when people are predicting the things that I'm going to talk about, because that means at least we're all like moving in the right direction together. So yeah, great question. And we will talk about how to do that in a minute. If you had no questions, either that means the material is way, way, way too easy, or nobody understands anything and I'm doing a bad job teaching. So, okay. So that's some of the ways you can use regular expressions to look for specific characters, ranges of characters, and 1 or more occurrences of different characters. And I just realized that all my examples of the quantifiers were using letters, but this works for numbers too. So hopefully in the interest of making this a little bit more obvious how to apply these things, because kind of looking at them in this very like discrete way is not terribly useful. But let's go ahead and we'll do a 2-part question. So for the first part, go ahead and write out a regex that would match both of these spellings of the name Sean. So I'll give everybody just not as long, maybe a minute to think about this one. And if you figured it out, feel free to give me a green check. Or if you're struggling, give me a red X and we can talk about it. Ooh, okay. Hello, Emilio. See that you have a red check, or sorry, a red X. Do you have a question?
No, I'm just saying that I couldn't do it.
Oh, you couldn't figure out how to do it?
Yeah.
Okay, that's okay. I mean, I will say you can use the square brackets for this. Oh, my timer's about to go off. So once we go through the one of the possible answers, I'll come back to you and see if it makes sense then. Okay, for folks who were able to get an answer, do you want to go ahead and put it in the chat? We'll go ahead and see if that works in the regex 101. This is really a great tool. I don't know how people would have written these beforehand. It would have been really challenging. Okay, sweet. We've got some answers in the chat. Okay, I'll start off with the first one. Okay, so this is from Carla. And this is the way that I did it too, just FYI. Yeah, so this regular expression will look for the characters SHA, and then the middle one is the one that is one of these two options, and then N. And so this will find, so remember the square brackets, it's looking for at least one of the two options. This will then also, I just realized that this will return some weird answers will also end up showing up. So I think, hold on a second, let me think about this. No, it won't work because it's only looking for one of them. Okay, never mind. Okay, so yeah, this is a way that you can use the square brackets to look for these two different spellings of the same name, or the same pronounced name. I guess they're technically two different names. So it's looking for, is there either a W or a U in that position? Okay. And yeah, so we have one answer that was close, but used a lowercase s. And this will actually not match, at least not exactly match the two strings that I had put, because this says it's looking for a uppercase s. But we could also look for both upper and lowercase if we wanted to. Does anyone know? So for example, let's say we're also wanting to match, this string. What would we put in the beginning to match upper or lowercase s? Yep. You have a curly bracket in there, but I assume that's not, it's supposed to be a square bracket. Yeah, like so. So you can look for, but you can put in both characters that you're looking for, upper or lowercase, because remember, this is all very case sensitive. Awesome. Yeah, Giovanni used a range in here, which would work too, because U and W are next to each other in the alphabet. No, oh, I see. Wait, okay, I'm terrible with that, but A, B, C. So it would match. Yeah, so we probably don't want it to match that. So maybe we don't want to do this as a range. We just want to include the two letters of interest. Good call. See, and there are all these like weird edge cases. And so when you're actually writing these, like if you have a long list of strings, it's probably helpful to go through and like look at all, or at least try to look at as many of the matches as possible to look for these weird cases where like, I actually don't want it to match that. Because while these are two different ways to spell the name Sean, this is probably actually a misspelling. Okay. Oh, bye, Carla. Oh, she's gone. Perfect. Anastasia. What if we tried to match to another spelling such as Sean? That is good because that's actually the second part of this question. So how would you match to, and again, there's probably multiple ways to do this, but what is a way that you could do to write a regular expression that will also match this spelling of Sean? So everyone wants to take a minute to think about that. And so this is where I started using quantifiers, by the way. a minute. So if you have a possible answer for this, feel free to put it into the chat. Oh, we have one already. Sweet. Okay, I'm going to just start over. So, will this work? I think we wanted to get rid of this lowercase Sean. It's just a single character present in the list below. So this doesn't match any of them. And I think that that's because it's just looking for one character that matches everything in the square brackets, not multiples. And I may have said that incorrectly earlier, so I'm sorry if I did. But so for example, I think this would match like this, yes, because it's looking for just one character that matches at least, or matches one of the things within the square brackets. And I may have missed it. I may have poorly explained that earlier. So that won't quite work. Anyone else have any other ideas about how to match all these spellings of Sean? Okay, so we've got a quantifier in there from Anastasia. You can put this in. So this is getting closer. I'm actually not really sure what the quantifiers do within the square brackets. I think the way that I ended up constructing this is, okay, started off with U, W, and okay. So I started off with what the answer was before, and then I used, let's see here, I used the question marks multiple times. And so if you remember that a question mark indicates 0 or 1 occurrence of a particular character. And so, yeah, what I did here is because of this spelling of Sean, we wanted the H and the A, the first A, to be optional. So I put and an E. And then this would be optional. Does that work? No, that doesn't work. Oh, the A doesn't need to be optional. There we go. Okay. So yeah, maybe this is a little complicated to construct, and there's probably a more clever way to do this, but I couldn't think of one. So basically what this regular expression is looking for then are matches that start with a capital S, and then may or may not have an H, may or may not have an E, and then has an A because all of these three have A's. And then may or may not have a U or a W, and then ends with an N. And looking at this, I realized I could also write this a slightly different way, I think. So the second character is an H or an E. So I could probably also do something like this. Oh, I didn't even need that. Something like that. Matches Sam. Oh, but this one doesn't. But the previous one did. Where I had, yeah. So this answer right here also matches SAN, which we wouldn't want it to do. So yeah, it's one of those edge cases that I had not thought about when I was putting this together. So yeah, I think these are pretty tricky, and it could take a little bit of time to get them, especially if they're kind of specific. And I don't know if there's a better way to do this than just sort of like this trial and error process. I think really it is just this trial and error process. Maybe someday Chat GPT will just be able to write all these for us and we won't ever have to do them again. But I think that's probably a long ways off. Because our brains are still really good at pattern matching and recognition. So yeah. Okay. Does these answers to this make sense? So again, this is using a quantifier, which is basically saying that we need to match something within these square brackets 0 or 1 times. And so that's how it captures the Sean, this third spelling of Sean, is because the U and the W are optional in effect. Okay, does anyone have any questions about that?
Can I ask you one thing?
Yeah.
Yeah. So
Hi.
in such a complicated case like the different pronunciation of the name or the spelling, sorry, of the name, is not then easier just like put like the different names that you want to like in kind of concatenated way, or it's like totally stupid? Because I understand that sometimes when you have like alphanumeric characters, it's actually nice to use the regex because it's like extracting information that you might have like coded in the name of a file or something. But in like names, probably if you have like Sean, I don't know how to say it. You just like take the three and then you put them. Yeah.
Yeah, definitely. And I think a case like this where you're really just looking for, if you just want like any instance of these three exact spellings of a word, you may just want to go through and extract each instance of those separately. Yeah. So again, these examples are a little simplified, it might not, but it's more for figuring out the mechanics of the syntax in a simpler way before you can build it up to more complicated things. But yeah, there might be cases where instead of spending all the time to figure out the regular expression, you just want to look for any instance of this exact string. Yeah, definitely depends on what you're doing. But hopefully through going through this material, you'll also have a better idea of when you should just jump straight to like, I just want this specific string, as opposed to I'm looking for like pieces of information that are a little more complicated than this. So yeah.
Okay, thanks.
Yeah, that is a good comment and a good thought. For sure. Yeah, in a case like this, if I'm specifically just looking for, you know, these particular strings, I might just look for those each individually. Yeah. Yeah, and the thing where this probably ends up being more useful, we'll talk later on about like capture groups too, how you can actually extract parts of strings using patterns too. So I think once it starts getting a little more complicated and you're actually trying to pull out pieces that are not just like Sean, it might be more helpful then too.
If I might ask another thing, just because we are like, I know it's probably coming later, but is if you're working in R, as you were saying, that probably we can apply this kind of expression in there. If I create a list of file names, I have to kind of convert the file names into strings before, so a list of strings, and then can I kind of loop inside that to look, for example, to certain characters or stuff to select just a group of files in a, it works in that way, right?
Yeah,
it's an application. Yeah.
Mm-hmm. Yeah, you don't even have to loop.
Okay.
Hopefully if I get to the demo,
okay,
you'll be able to see, but there's yeah, at least in R, you actually don't have to loop through the different strings. You can just give it a list of strings, a vector of strings, and then it'll return each of the strings that fulfills that condition from the regular expression. Like there's no looping even involved. It's really easy.
Okay.
Yeah, the stringer package is the one that does those. So yeah. Yeah, if we don't get to it, I can send you like some snippets of the code that I was going to go through, and then it'll probably help explain it a little more easily. Yeah, good question. Yeah, and again, how this works for some of the programming platforms, like I mostly work in R. I could probably figure out how to do this on the command line too, if people are interested in that. I imagine I could figure out. I know a little bit about the tools in the command line, but not a ton. But then Python, I'm sure, has really good support for this, and probably all of the other programming languages does too. So it would just take a little bit of time to figure out exactly how to give those functions in the programming language the information, including the regular expression. Yeah, it's a good question. Okay, we will keep moving on to, oh, yeah. So these are the additional quantifiers. I was talking about the curly brackets earlier, and this is what we're talking about now. So curly brackets are used to specify the number of occurrences of a particular string or a particular character. And so the way that you use these is you have your character, and then you have a curly bracket, and then you have a number inside. And so what this is basically looking for is 3 consecutive occurrences of capital A. And so these are the strings that would match, 3 capital A's, ba, like a sheep, bo, 3 capital A's. But then 2 capital A's will not match because there's only 2 instances. So it's generally how these curly brackets work. Curly brackets you can also use not just, one particular instance, but a range of instances in this way. So let's say you're looking for repeated A's that are repeated anywhere from 2 to 4 times. And so that's how you specify that here. So it's 2 to 4, separated this time by a comma instead of like the dash, which is what you might expect, but it's a comma for some reason, and no space here. Just to note that. And then, yeah, so now knowing the curly brackets, I have an exercise that you can sort of pull some of this stuff together to do a slightly more complicated task. Hopefully this will seem a little bit more realistic to what you'd look for in your data. So the example here, and so this is going to be a multi-part question. We'll sort of work through these as I add different examples of date formats. And we're going to start off with a pretty simple date format that most people are probably familiar with. So I want everyone to go ahead and I'll give everyone 2 minutes to work on this. Go ahead and try to figure out how to write a regular expression using square brackets, curly brackets, how to match a date. And we'll just start off really simply with matching this particular date. This happens to be my birthday. But you can use any date if you want to use a different one than this. Yeah, go ahead and take a few minutes, and using regex1, go ahead and try to construct a regular expression that will match this date. Or match dates of this format, I guess. But also, this is a specific example. So, one that's month / day / years. Go ahead and set the timer. Okay. So, I didn't mute myself, did I? Okay, no, I did not. Okay, so was anyone able to take a stab at that? Even if you have a partially correct or just something, feel free to post it in the chat. Oh, I like that. Okay, Harsha has an answer that was not the one that I came up with, but I think is actually better already. Okay, so here's the regular expression that's posted. And then here I put in an example of a date. I mean, you can put in any date you want. But so to break this down, this is great. This looks really good. So remember the \d stands for any digit, and then you add on the curly brackets. And this is great. This is even further than I was thinking, but add on the curly brackets to say you want 1 or 2 numbers. And then you have a dash, and then the same thing for the day. And then at the very end for the year. And so this is great actually, because this captures some of the edge cases that I was thinking about before, which is if you have people entering dates that, like, for example, don't have the beginning 0, or if they're entering a day earlier in the month, that also doesn't have the beginning 0, the leading 0. And then if people are entering the year, but just the last 2 digits. So this is awesome. Yeah, so you can see where this captures multiple different formats of dates really, really nicely. And so it could be that you're being very specific about checking for dates that are in this format, and you really want them to like have, 0308 1990, like the full year. And so you could go ahead and modify this and say, I only want to accept dates that have, both digits for the month, both digits for the day, and 4 digits for the year. So yeah, so that's awesome. That wasn't even the answer that I had thought of. Mine was this, which is similar, but it's basically saying we want, so remember that the brackets with a 0 to 9 are equivalent to the \d. But the \d is nice because it's a little shorter. So yeah, really similar construction, but I really like that. Looks really good. Awesome, thank you. Oh, how would we modify it? Yep. Yet again, predicting the next question that I have. I love that. Okay, so in order to do a date format that is separated not by dashes, but by slashes, we have to know how to escape. Because if you remember, that's \ is a special character for regular expressions. And so you have to figure out how to escape that to use it as an actual \ as opposed to something that's part of like, /d. I guess the slash goes the other way. What is the other slash used for? I can't remember. Yeah, the front slash, sorry, thank you. The front slash is a special character in regular expressions. I just can't remember what it's used for. Because the \ is used for any alphanumeric character, that \w, and I can't remember the / is special for. It does, you start off your regular expression with it, so maybe that's just it. But yes, so how do we say, I'm actually looking for this character, not as the regular expression flavor of it. And so that's where we're going to talk really quickly about escaping special characters. So the way you escape a special character, if you want to use it as is by using a slash. And so, for example, we talked about how this plus symbol is a quantifier, but let's say you actually want to look for plus symbols, not just use it as like indicating the quantifier. You want to put a / in front of that. So anytime you want to escape a character and use it as is, you put a / in front of it. And especially in R, when you're writing out regular expressions, this becomes really important too, because of how many things they use as regular regex characters. So I think then if we want to include a date like that, so we want to look for dates that have slashes instead of dashes, we can go ahead and escape those characters. The \/ like that. Okay. So just a really simple example before I'm combining both of them, but if you're just looking for dates that are separated by /, you have to include the /, but you also have to escape it by including a \ before that. So you see how these two are put together? And again, the regex 101 is really helpful in the explanation. It says right here that the 2 slashes put together matches this character as opposed to being a special character in regex. So yeah. So can anyone take a stab, knowing that information, can anyone take a stab at adding to this regular expression so that it will include both dates with dashes and dates with slashes? how would you modify this bit right here? I'll give everyone a few minutes to think about that. So basically we want a regular expression that will capture both this format of date and this format of date. Oh, and I should have set a timer because if I don't, I'd have no idea how much time has passed. Everybody a minute to think about that. And if you think you figured it out, feel free to give me a green check mark. Okay, so this is about a minute. Was anybody able to figure out what to add here in order to look for dates with both slashes and dashes? Feel free to put it in the Zoom chat or you want to say it out loud. So I thought a couple of green checks. Square brackets, anyone? Okay. So the way that I would do this to make it look, so to make the regular expression in this spot look for either a slash or a dash is, okay. Someone did put in an answer. Sweet. Okay, thank you, Anastasia. Here, I'll just take your whole regular expression. It's very similar to what's there, but with a little added bit. Okay. And so this right here, everything within this first set of square brackets is specifying what goes in this third position. And so we have either a slash with an escape slash or a dash. And I am wondering now, I think you don't need match all three date formats. Yeah, well, you don't need the comma. People don't write dates like that too, do they? Like, are there people who write dates like this? Because if you do see that or it's a format like that, it would capture this. But I actually think in this, for this, you actually don't need the comma. Although it doesn't do anything harmful unless it then accidentally captures these date formats if you don't want them. But yeah, otherwise that's perfect. That's exactly what we're looking for. Yeah, so if you remember the square brackets, it will look for that position, something that's within the square brackets. Yeah, that looks really good. And I mean, from this, we've only been working at this now for not even an hour and a half, and we've already built up these kind of like, I mean, just looking at this by itself, this regular expression, I mean, it looks like a mess, right? Like it looks really confusing and complicated. And so that's why I think it's really important with these regular expressions to really build up like from the most basic. And then as things get more complicated, you add and modify things. And then you end up with these things that just look like, they're written in an alien language. Yeah, great. Okay. I think we're going to skip those. Does anyone have any questions about this exercise? About any of these syntax options? Remember, there are many ways to do things too. I think I added in a couple more examples of dates stuff here. So, and I did some of these things a little differently than some of the suggestions. So. But yeah, so any questions or thoughts?
I won.
Yeah.
just by trying something strange, I realized that the expression that we have written just before can match also if you flip the year with the month. Is there a way to ask for just 2 digits for the first part, just 2 digits for the second part, and 4 digits for the year?
Yeah. So
Because if you write, for example, 1990 0316, that should match it as well.
yeah, so if you want to match something like this,
Yeah, that's not correct because it's not the right format, right? You put the year first and then month and day. So is there a way to put like in the first part, like slash digit 1 or 2, but like maximum 2, something like that? I know it's complicated.
yeah. I think there's a lot of ways of going about this. You could, let me take a shot at this. So you could do something like, and I actually did this in the example, I think, something like this. Oh, it's still going to match it though. And we want 1 exactly. So actually maybe something like this, but that still doesn't help. So I think actually the thing that I would use here to make sure that it doesn't match this date format, although it's not matching it now because it doesn't start with a 0. Oh, it starts with a 1. Okay, so this does actually work. Okay. Yeah, so here it's looking for a 0 or 1 in the first position, and then it's looking for exactly 1 digit next. And then because there's these 2 extra digits here, this does not match. So can you see how that would, I think this is one of the ways to answer the question that you're talking about. The other thing that we'll talk about in a little bit are anchors. So you can specify what, I don't think that would actually help here, to be honest. Yeah, anchors actually wouldn't help with your question, so never mind, but we will talk about them. That's basically a way of specifying what's at the very beginning or very end of a string. But it's not relevant here. So yeah, does that answer your question?
Yes.
Okay. These are really good questions, and it's good because it's helping me also see if I actually have learned some of this stuff. So yeah, great. Okay, in the interest of time, we'll kind of keep moving along, but feel free to interrupt me at any time. Oh, anchors. It's a very nice thing. Great. Okay, so yep, anchors are a way of specifying what a string starts or ends with. And so this can be really useful for these cases where like you want a string that doesn't have a bunch of extra stuff at the beginning of it because it's not the right string that you're looking for. Those are the cases I think of using them in. But so the anchor that you use to indicate what character you want the string to start with is a caret. And so here we have an example of a caret and then a capital T. So it will match with any string that starts with a capital T. So it does not match these tiny t's because it's looking for a start with a capital T. And then there's an anchor for the end of a string. So the end of a string anchor is a $sign. And so it'll just look for that character at the end of a string. And I think it does. I think we have to talk, never mind. I think we have to talk about something else to talk about that first. Sorry. So yeah, so for this example, it'll look for any string that ends with an S. So yeah, those I think can be really useful. And then we'll just run through a couple of other miscellaneous regular expression syntax that can be really useful, or that I've seen these pop up a lot in some of the examples I've seen, so they're good to cover. So there is a just a period by itself refers to any character at all. So we talked about the \w, which is for any alphanumeric character, and \d, which is for any digit. A period will match any digit at all. So I think one of the things I've seen this that is useful in is if you're looking for like any 3 characters, but just 3 characters, you could put a period, curly bracket, 3, and then an end bracket. Okay, this is another useful one, or potentially useful. This happens actually in my data a lot, where you might end up with a bunch of white space in strings where there isn't supposed to be any. And so \s will look for any string that has white space in it. So it works if there's like strings that basically are like sentences with multiple words. It'll also look for tab white space, like this one right here. So if you're like trying to filter out or clean some data and you want any data that doesn't have any white spaces, for example, you could use this to find the ones that have white space. Okay. Oh, and then there's the conditional, which is indicated by this pipe here. I kind of did this out of order a little bit, but a conditional is basically looking for one of two options, but more than just one or another character, but groupings of characters. This then requires us to talk about capture groups, though. So basically what this regular expression is looking for is any string that is TR and either AP or OOP. And so, yeah, we'll talk about capture groups are what are in the parentheses. So, but the important thing that we're talking about here is the pipe, which indicates this or this. And I don't know if you can use more than one pipe, but within the same group. That's a good question that I just thought of. And I'm not really sure if you can just use one or if you can use multiples. But yeah, so this regular expression will match trap or troop, but won't match, anything else. Okay, and then, oh yeah, so I talked about capture groups yet, but I should have talked about them first. So this is actually a really, oh, I like that. Okay, so Erica has a good answer for the Sean thing that we were talking about earlier using options and capture groups. So that's pretty neat. I like that. I'll show that really quick. It was a really, oops, copying didn't work. It's a really fast application of a concept. So we had Sean, and Sean. Yeah, so just including the 3 different options here for the middle spellings, and then we won't get any of those like weird edge cases like San, or I think this won't even get SN because you need at least one of these options. Cool. Yeah, that was a good example like that. So these capture groups are nice for 2 things. One, they'll look for like groups of characters together. So basically it's like saying, I'm looking for this group of like these 3 things or 4 things or however many things you put in there without the conditional. But then this is also what is used. Then a lot of the programming tools have the ability to extract parts of strings that match a pattern. And so the capture groups are also what do that. And we'll talk about, I think we're going to go through an example that hopefully will make that a little bit clearer. But this is the basics of capturing groups. You have your parenthesis and then whatever you want to capture or whatever you want to group is within there. And so, for example, we have the, oops, can you move that? We have the within our parenthesis that is our capturing group. And so the string the or there will be a match. This will not be a match because it does not match what's in the capture group. And then you can use the programming tools to then extract out whatever matches. And so if you run some sort of extracting tool on this capture group using this regular expression, you can pull out the or the. And so again, this is a little bit of a trivial example, but I think we're going to go through an example of where these capture groups are really nice for pulling out things like, I think the example that I have is file names that have dates embedded in them and a way to pull out just the dates, even if they're in slightly different formats. So yeah, so it's capturing groups. Here's a summary of all those things. We talked about anchors, escaping, capturing white space, and the any character regular expression. Okay, so I have another, this is another exercise. It's got 3 or 4 parts to it that we can kind of work through together. And so we're going to start off with a very simple example. I think these are particularly useful, especially to follow along with, because this is how you might actually work on these, like how you might actually develop these complicated regular expressions. You're not just out the box going to like be able to account for every single weird edge case. You're going to have to figure out what you want to have it match and not match, and then increasingly modify your regular expression. And so I try to set up an example here of that. So in this case, we're going to try to match a species name. So this is something that happens in my work all the time, is that I'll have like a vector of species names, and I'm looking for a particular species name from those. And so Acer rubrum is a red maple, I think. I don't actually study trees. It's just one of the ones that I thought of randomly. But let's go ahead and start off writing a regular expression. We'll just do this one together because it's fairly straightforward. But let's write a regular expression that will match Acer rubrum, and it will not include anything that has any white space. How did I do this? I actually don't remember. Ah, yeah. So I used anchors for this. Okay, so I want my regular expression to match Acer rubrum as is, but I don't want it to match. I'll separate these. I, for example, don't want it to match anything that has white space at the beginning or end of the string. And so this is where I would use anchors. So I put my caret anchor at the beginning to say I want the very first character to be a capital A. And then I want my very last character to be a $sign. And so you can see here, it's a little bit bigger. You can see here that this regular expression will capture my species name, but if there's any white space at the beginning or end of the line, it will not be included. Okay, but let's say I'm looking through my data and I'm looking for more matches for this particular species name. And let's say that I see some instances of this misspelling of the species name, but let's say I still want to return those. I still want to return those as matches because even though they're slightly misspelled, maybe I still want to use that data. And so I want everyone to go ahead and take a minute to take this regular expression and build on it by including it matching this misspelling of the species name. So figure out how to modify this regular expression to match both of these. And I'll go ahead and paste this into the chat. I'll give everyone a minute to work on that. Oops. Okay. And if you're able to successfully get that, go ahead and give me a green check. Okay, that was about a minute. If anyone was able to figure out how to include this misspelling in the regular expression, you want to go ahead and put it in the chat for me. I saw some green checks, so somebody has it. Okay, sweet. Yes, that is definitely one way you could do it, using some of the new stuff that we learned. Oops, oh gosh. What did I have here? E. Okay, so this is one good way to do it. So we use that capture group like we did before. Well, Anastasia used the capture group like from before that we just learned, and then you put in the option of either U or E using that pipe. Yep, so that's perfect. That returns either of these. Eric included an answer that also probably works, but it's a little silly. This will also capture both misspellings because it starts with an A, and then this right here indicates any character, and this uses one of those quantifiers, any character any number of times, including 0 times. And then it will end with M. The problem with this one is it's going to match a bunch of stuff we probably don't want. Like it will match just AM, or it will match, you know, a bunch of numbers M. And it'll also match attention mom if you're looking for that for some reason. But probably if we're looking through a list of species names, we don't want that. And I imagine there's species names that also start with A and then end with M that are not Acerubrum. So technically will work. So thanks, Eric, for the contribution. But probably not what we're looking for. Okay. But yes, also, so Anastasia's answer was really great. I think the answer that I ended up putting was similar. Just like in all programming, there's a lot of different ways to solve the same problem. Many that are valid, or it depends a little bit on exactly what you're trying to do. So yeah, so the way that I solved that was by using the square brackets and the UE, so it'll match one or the other, but not both. Okay, so we're sort of building up. Now we're matching one of the misspelled versions of the species name. Let's say we also notice that there are some instances in our data where they use the abbreviated version of Acerubrum. So it's really common in scientific names to abbreviate the first word to just the first letter, Arubrum. So can you think of a way that you can then further modify this regular expression, or Anastasia's, which was also great, to also capture Acerubrum or Arubrum? And so right now it's not capturing that because it includes this exact match to CER. So I'll give everybody a minute to think about what you might add to this regular expression in order to also match the abbreviated version of the name. Okay. Hopefully that was enough time to at least start thinking about this. Yeah, if anyone has a regular expression that is modified from this in order to capture the abbreviated version, could you put it into the chat? Anyone? This is hard because you're applying stuff that you maybe have just learned, so totally understandable if this is a lot. Also, I wasn't sure of a way to maybe provide like some of these summary sheets to y'all. That would have been helpful too, probably, for these. Okay, so the way that I think I went about doing this was using a capture group around the CER, and then I used, I think it's the question mark. Yes. Yeah. Okay, so yeah, what I did in order to make the CER optional is that I made a capture group around the CER, and then I put the $sign behind it. And so $sign says we want to match whatever's in that group 0 or 1 time. So yeah, does anyone have questions about that or how that works? And again, there might be other ways to do this too. That was just the way that I thought of. And Eric also has some other options. Yeah.
Is there,
yeah,
maybe you're going to get to this with the capture groups. Is there an advantage to using the capture group to make it optional instead of just doing like, oh, I guess it would, okay. I guess this would, the one that I did with the dot asterisks would also capture if there was like some other genus name that started with A and was like longer, it would also capture that.
Yeah.
Oh, okay. So that's better. Answered my own question.
Nice. Yeah, because the things you put, I think, are a little more generalized because anything can go in there, whereas it's nice here to have the capture group for CER because we're really specifically looking for that. Yeah. Good to talk through that. Does anyone have any questions or thoughts about this? Yeah, so I think these are a little tricky. And again, you kind of have to iteratively build them up and practice, I think, in order to become comfortable with these. And I think one more example. Oh, how to make this case insensitive. But we talked about that. So one of the ways you can make something case insensitive is to include the capital and lowercase letter in brackets. So yeah, I think that covers all of the syntax that I'm going to cover. There's other syntax, especially if you're doing some different things in this that you probably want to explore. So maybe I'll come back to the demo in a second. I'm gonna go first to the resources page, because one thing that I want to point out, make sure everyone's aware of, is that there's also some nice online exercises for practicing these. And so the one that I linked to here in on the resources slide is this regex 1. This was great. I went ahead and actually did all of these to learn and prepare for this. Some of my examples are a little based off of their examples too. So full disclosure, I'm staying on the back of giants here. But yeah, so this is a really nice tool for going through all these different concepts again, and then also practicing them, because you, in order to sort of go on to the next one, you have to figure out how to write the regular expressions that will match or not match some of these examples. So I highly recommend, if you're trying to practice these more, especially because it's probably seemed a little overwhelming by the last exercise, is to go ahead and walk through this sort of online learning tool. There's probably others that are really great too. This is just one of the ones that I found when I was preparing. So yeah, highly recommend this. Oh, and yeah, as I showed at the beginning, but I want to show again, this, I don't know how you'd say it, regex per. But this is a nice visualizer for your regular expressions. So we can take that last regular expression that we wrote and put it in. And then, oh, this is really small. Make it a little bigger. So this is really great because it shows you what all the different components are in a more visual way. So you can say like, okay, we know we've got the start of the line, and then the start of the string, and then you need an A, and then you need a group that's optional. So you can see they indicated that was optional with the dotted lines, and then you want RUBR, the space, and then one of these two options. So just really nice, like they puts it in a nice visual way too, that can help you figure out. This is probably really helpful for your debugging too, if you're really stuck on something and can't figure out how to get it to work. So this seems like a great tool, also free. This is all free, all online. It's actually really nice to teach a workshop that doesn't require installing or downloading anything. Yeah, there's a lot of tools online. Ooh, regex crossword puzzle. That looks cool too. Oh, there's probably a bunch of these.
It looks really hard.
Oh gosh, okay.
The tutorial is easy, but then as soon as you get to the beginner one, I'm like, oh, I have no idea.
Well, maybe for a lot of practice after you've done it
really into
a bunch of
really
times.
into it.
I mean, yeah, I don't know how many of those I'll be doing myself, but cool thing to link to. Awesome. Yeah, and there's some other materials on here that are just some of the pages that I used to prepare this material. So I mostly wanted to point out that, yeah, doing some practice and then using these online tools for writing our regular expressions, I think is probably the way to go. But hopefully you have a little bit better of a grounding in how to write the regular expressions to get you started. Because obviously if you just opened this up and didn't know anything, like it'd be really hard to trial and error without having a framework. But yeah, I wanted to go through a little demo. I guess in particular, Giovanni, this will probably be helpful for you. But basically like a short little demo for how to use tools to do stuff with strings. And I'm using the R language in particular, so sorry for folks who are not familiar with R, but if you are familiar with programming or the command line, hopefully it'll be enough for you to learn a little bit from. And this will only take a few minutes, but in the R language, there's a package that is called Stringer, and they have a whole series of functions that are super helpful just for working with strings in general. But one of those things in particular is using regular expressions to match and do things with strings. And so there's 3 functions here that I highlighted: string view, string detect, and string extract. So I'm just going to walk through those real quickly in the last few minutes. Sorry, I need to get Studio up. And my notes have disappeared. Oh, they're there. Okay. So yeah, just as an example of, this will probably don't try to follow along with this part, by the way. This is a demo, so just feel free to sit and watch. Okay, so I'm in the R programming language right now. Let me make this a little bigger so you can actually read it. Okay, so I went ahead and I put together 3 strings to start with. And so these strings are just animals, basically. And so there's to use those stringer functions I was talking about earlier. So string, let me read in the library so I don't have to type it in every time. So there's this function called string view. You can give it all of your strings at once, like I talked about before, and then you can give it a pattern, which you can give it a regular expression. So if you remember back when we learned anchors, the end anchor was $. And so here, what this is doing is it's going to look through each of these strings and look and see if this regular expression is fulfilled by any of them. And this particular regular expression is looking for any string that ends with an S. And so I'll hit enter. And this is actually really nice. So this string view will show you what parts of each string match that regular expression to. And so here it highlights that the first 2 strings are a match because of these 2 S's, and then the last string is not. So this is a really nice tool for debugging. I don't think I'd per se start off writing regular expressions in R, but this is a good way to test and see if what you're doing works. Additionally, there's another function called string detect. And so this will return just whether or not those strings are a match for the regular expression. And so other programming languages also probably have similar functionality to this, where you can give it some strings and then a regular expression and then say, hey, which of these is a match? And so in this case, the first 2 strings are a match and the third one is not. And then the third function that, at least so far, there's other ones too, but the ones that I've found just quickly that were useful is the string extract. And so what this does is, we were talking about capture groups earlier, and I'll show an example of those in a minute. What this does is it says whatever matches in the string to this regular expression, I'm going to pull it out, pluck it out, basically. So here it just returns the parts of the string that match the regular expression. And so this is maybe not the most useful example, but we can start see here. Let me do this. So I'm going to create a second list of strings, also from our example earlier. So let's say that we have these strings, the, there, and this. And like we did before, let's say we're trying to we're interested in the instances of the in any of these strings, but let's say we want to actually pull out the, and so that's where we would, so if you just do this, it extracts it, but also you can start using capture groups here. And so it will only return whatever is captured within the capture group. So I'm trying to explain this really quickly and well, it pulls up the whole thing. How does it do that? And I had a better example here that might illustrate this more. But capture groups are great for not only identifying strings that match your regex, but also pulling out the parts that match your regex. And this is a task I do a lot, and this might be a good motivating use case for regular expressions. And so I try to set up an example of this, and I'll show it real quickly. I don't want to hold anybody too long, but so let's say we have a list of file names, and I just made these up, they're not real, but let's say we have a list of file names from a camera that was taking pictures on certain dates. And so you can see you have one here, camera 1 on this particular date, .png. We have another one, so there's 5 of these here. And I wrote a regular expression that will basically say, okay, I'm looking for a string that has this file extension, PNG. I just looked for PNG. And I'm looking for one that starts with camera or cam. And then I want to pull out this date here. And then there's one right here that even has, at the end of the date, has some extra junk underscore text. And so I wrote this regular expression in R. So it's a little different, but oh, actually I ended up making it. No, it's all the stuff we've already learned. And so this regular expression right here matches the date, or matches the entire string in that it's looking for something that starts with cam and ends with .png. And so it excluded the last two because this one doesn't have camera at the beginning and this one doesn't have the file extension. And then I made it a capture group too. So I put these parentheses here to say, then I want you to pull out the date from those different file names. So you can see that in the second column here. And so this is starting to hopefully, I'm just trying to demonstrate an example of how this could be useful in your real work where you're working with messy data and you're also trying to like pluck out these patterns and use them on their own as some sort of information. And so here's an example of where you could have all these file names and you're really just trying to pull out the date information. And we walked through how to construct regular expressions for different formats of dates too. So you could have even more complicated file names with dates in them that are in a bunch of different formats. But now you have the skills to be able to write a regular expression like this that could be even more complicated that will pull out dates of many different formats even. So it's a very flexible and very powerful tool. And so yeah, whatever your preferred programming language is, you are hopefully now at least feel a little bit more confident that you're capable of building up these regular expressions to be able to pull this useful information out of these strings. So I was a little crash course. Hopefully, Giovanni in particular, that was helpful to see at least a little bit of how to do that. Sorry, I was really fast. That is the sort of thing we can do workshops on.
It is helpful.
Okay. Hopefully at least get you started when you do these tasks. So yeah. So I ran out of time there a little bit at the end, but yeah, so that's that question I was just talking about. Resources. And then so to wrap up sort of the last little things, it would be great if everyone could take this survey, and I can put this link in the chat too right now, but I will also send out an email. Oh my gosh, I just want to copy this. It's really, really helpful for us to get some feedback from you about how this workshop went. If it went terribly, like, please tell us, because that's also useful information for us to know. And they are anonymous. So don't worry about that. But yeah, so we have this survey here. Make sure that you select this workshop, which is it was supposed to be the one in January, but ended up being in February. And yeah, just answer. There's a few questions. It should only take a few minutes to fill out, but it'd be really helpful if you could fill out this workshop or this survey for us. I will send out an email today or tomorrow that has the link to the survey. I'm also going to put the recording on YouTube, so I'll send out the link to that to y'all, and the link to the slide deck, so you can refer to it later. And feel free to share with people, let people know about it. who could benefit from it. And otherwise, go forth and write some regular expressions. And if you need help with writing regular expressions, obviously this was just kind of a quick crash course. We can feel free to come and we can talk about it. We can figure things out together too. So we've got our drop-in hours, or you can email us. You can send me a message on Twitter, whatever. We're here to help. So thanks for coming. And have a good rest of your Wednesday.